All right, 12.2 are called measures of central tendency. So central tendency means a singular number that is in some sense a representative of the whole set of numbers. It's kind of like a middle value. A lot of times when we think of like the middle value of anything, the most common thing that we think of is an average. You know, what was the average score on this test? What is the average amount of points that the team makes every game? What is the average amount of days that you miss from school, or so on and so forth? Averages are something we use or we think about quite a bit. And in math, we don't necessarily call them average, but whenever you think of average, what you generally do is you take all the numbers, you add them up, and then you divide it by the total number at the end. That's how you would find the average. And that's actually what mathematically we would call the mean. The mean, or the arithmetic mean, is found by adding all the items of a set of data and then dividing the sum by the number of items. So that's written in words. It's denoted by x bar, which is x with a little bar over the top. And then this is actually like the mathematical equation of what mean is. So this says mean is the sum, this little e is sum. It's the Greek symbol for sigma, which means sum, which means you add up all the different totals, and then you divide by the number of data points. So if I wanted to figure out the average grade of all the students represented in this class, what I would do is I would add up each of your individual grades, and then I would divide by the number of students in this class, and that would tell you what is the average grade in this class. So mean, median, mode, hopefully those are 3 M's you've heard in a math class maybe way back in the dinosaur days. But we're going to revisit them now, and we're going to see how they help us measure central tendency. They're going to help us see a general representation of what's happening within our data sets. So here's an example. We're going to find the mean of a list of sales figures. It says last year's annual sales in dollars for 8 different online businesses are shown as follows. So these are 8 different companies, and they show you what their annual sales were for last year. We are going to find the mean of the annual sales for the 8 businesses. So mean is the x bar, which is the sum of the x divided by the number that we're dealing with. In this case, we're dealing with 8 different businesses. So what we're going to do is we're going to add up all of these totals from their sales. And if you do that, if you type in all 8 of these numbers, you get $2,682,712. And then there's 8 different companies. So we're going to divide that by 8. When we do, we get an average or a mean of 335,339. One thing the mean allows us to do is it allows us to see who is above that and who is below that. So if you think of mean as the average, it's like whose sales were above average and whose sales were below average. Whose grade in this class is above average and whose grade is below average? How do we improve that if we need to? Or how do we maximize that if it's a sales thing? And so when you find mean, that's all you're doing. Now, last class, somebody asked if they are required to use Excel in this class, and I stated you are not, and you don't have to. Some of the problems, though, when you're doing mean, you may have 40 different pieces of data. And so you're typing in 40 different this plus this plus this plus this. On Pearson, there's it'll give you a little window that you can click, and it gives you all your data in a table, and it's called StatCrunch. And it gives you an option inside of that window to export into Excel if you want to. And so you do get the option to use Excel if you so choose. One of the benefits of using Excel is Excel will add up all those totals for you. So you don't have to use Excel. I didn't use Excel when I made my notes or did any of the work that I did. I just did it the old-fashioned way. But Excel would expedite or speed up the process for you. So feel free to use it if you so choose. When it comes to a paper pencil test, like the final exam in here, I will make sure that the data amounts are small enough, like 8 not 40 or 88 or anything like that. So that way it's easier to compute, because for me, it's not, can you find the mean of 2,000 data sets? I'm sure you could, but that gets really tedious. If you can do it for 8, you should be able to do it for 2,000. All right, grade point average is another great way that you can use mean. The following table shows the units and grades earned by one student last term. And so it shows you they got an A in math, a C in history, so on and so forth. But they want us to find the grade point average that this student earned last semester. So what we have to do is we have to know a couple other things. Now, on Pearson, they would give you all this information. On here, they don't so much, because this is straight out of the book. So here's the additional information you would be given. A's are worth 4 points. B's are worth 3 points. C's are worth 2 points. D's are worth 1 point. F's are not worth anything. This is true for a standard grade point average. So this is how your college grade point averages are found, is they take the units, that's the number of credit hours you were receiving for a given course. They multiply that by how many, if you get an A in it, then you get 4 points for that. If you get a B in it, you get 3 points for that. And then we find the mean based on that. So if you are a person that likes steps, here's your steps for finding grade point average in this problem or on your own. Step 1 is you're going to multiply the number of units by the number assigned to each grade. So that's what we're going to do first. And I'm just going to extend my table really for that. I'm going to take the number of units times the number assigned to each grade. So I'm going to call those grade points. So for my A, they get 3 points. So 3 times 4, or 4 times 3, however you want to look at it, would give them 12 points for that. For a C, it's 2 times 3. That means they earned 6 points for that C in history. For physics, though, it's 5 units, but they got a B in it, so that's 3 points times the number of units, which is 15. They got a B in art, that's 3 points times the number of units, which is 2, giving them 6. And for PE, they did pull out an A, so 4 points times 1 unit for that will give them 4 points. So we figured up the grade points, that's step 1. Step 2, add the products. Add the grade points. We have 12 and 6, 15 and 6, and 4. So here's 10, that would give me 25, 31, 43. So total grade points is 43. Your last step when figuring out grade points average is to divide by the total number of units. This is finding a weighted average. We're still finding an average because we're taking the total grade points and we're going to divide them by the total number of units that the student earned. But it's weighted because each of these units had a different weight. It was given more points than the other based on the grade that they earned. So we have 3 and 3, that's 6, 5 is 11, 12, 14. They earned 14 credits last semester. So we're going to take 43 grade points divided by 14 credits, and that's going to give us a GPA, a grade point average, of 3.07. This is literally what the computers do every semester when you guys get your grade point averages. It takes how many credits did you earn for that semester. You're enrolled in 15 hours, let's say. Then how many actual grade points did you earn from that based on the grades you earned in your classes? Then we're going to divide that by 15, and that's going to give you your GPA. And what's nice about Southern is they compute your GPA every semester, but then they also do your overall GPA, where they look at all the total credits you've earned the entire time you've been at the university. So you can actually figure this up yourself now that you know how it works, because this is the standard point system that is used here at Southern. A's are 4, B's are 3, C's are 2, and D's are 1. There are some schools, maybe you went to a high school that had a weighted GPA, and you had people graduate with a 5.0 or something like that. And that's because they split up their grades a little differently, and maybe like a 95 to 100 was given a 5.0 grade point, and they earned more points based on the actual letter grade that they earned. And so there are different ways to do it, but this is the standard scale that is used by most places. Are there questions on how to figure out grade point average? Grade point average is just a specific form of the weighted mean, which is what is considered on the next page. The weighted mean of n amount of numbers that are weighted by the respective factors of f of 1, f of 2 is calculated as followed. So this W bar is what we just found. This W bar was our GPA, because what we did is we took our credits times the grade points that we earned, we added all of that up, and we divided it by the total. It works the same way. In words, it says the weighted mean of a group of weighted items is the sum of all the products of the items, weighing factors, and divided by the sum of all the weighting factors. I think that's way more confusing, to be quite honest, which is why I like doing the example first and then telling you it's the exact same thing. Grade point average is just a specific form of weighted mean. But you can use weighted mean to find other things. So we're going to use it to find the mean of the frequency distribution of salaries. This is going to be important as you go out into, quote unquote, the real world, not that you're not already in it, but when you go get a job and you're trying to figure out who's going to pay me better, is the average pay here actually a good representation of what's actually happening? Because what I told you in 12.1 is if you gain nothing out of this class, it's if somebody tells you the average of something or somebody gives you a stat from something, you always need to question what that stat is actually of, because I can make things sound really good in my company if I tell you that the average pay for my company is $75,000. But what I don't tell you is I make $250,000 and I'm included in that average, which totally skews everything. Because my employees maybe only make $20,000, but with me in that average, I'm going to skew it to make it sound great. So you always want to know where is the information coming from so that you actually have a proper representation of that company. So this question says we're going to find the mean salary for a small company that pays annual salaries to its employees based on the tables shown here. This is a frequency distribution table. So remember, we talked about frequency last time. Frequency is the number of times that specific number pops up. So this has a salary column and a number of employees column. And so if we go down to salary, $12,000 is here, and next to it the frequency is 8. So that means 8 people in this company make $12,000. We go down and it says 11 people make 16, 14 make 18.5, so on and so forth. And so for us to figure out what is the mean salary for this company, we're going to do a similar process to what we just did with our GPA. We are going to take the salary times the frequency that it occurs. So we're just going to extend this table over. We're going to take X times F. Bless you. So I take 12,000 times 8 to get 96,000. We take 11 times 16 to give me 176,000. Then you get 259,000, 189,000. We get 68,000, and last we get 50,000. So I took the salary times the number of employees that receive that to get my weighted mean over here. Now, down here in the bottom, I'm going to also put an extra row for my total. Let's figure out how many employees we actually have. 8, 11, 14, 9, 2, and 1. If I add all those up, this company has 45 employees. And if I add up all of these frequency salaries that I just computed, I find that there was $838,000 is what's being paid out to these 45 employees. So if I'm finding the weighted mean, which is my W bar, I'm going to take the 838 and I'm going to divide it by 45 to see what the average is. $18,622.22. So if this company was marketing itself, it would say that the average employee makes $18,622.22. That can be a little bit deceptive because in reality, if you look at that, all of these people up here, so there's 25, there's 33 of the 45 people that work for this company actually make less than that. But they could tell you the average pay is $18,622. And they're not lying to you. It's just been skewed because we have these 9 people that make $21,000, 2 that make $34,000, and this one person that makes $50,000. Having those extremes definitely outweighs the ones that are less. And so this is where we have to be careful when we're reading information based on companies, based on how much they pay on average or how much they donate on average and things like that, because we really need to look at what that data is that they're using. It sounds okay, if we say that they make $18,600 a year, but like I showed you, 33 out of 45 actually make less than that. So the majority of people who work for this company don't make that. So there's an additional note that says mean averages can be misleading, as I'm pointing out. When one or more of the factors is not normal when compared to the others, it throws off that average. So if you have 8 people making $12,000 and you got one person making $50,000, that person making $50,000 is going to greatly skew everything else. So means are okay in kind of looking for the middle of the road, but they're not always the best. Because if you have these people that are making a lot of money, or you have somebody who got 100% on the test, that's going to skew the overall average. And so that's why a lot of times we'll look at median. Median is another measure of central tendency that's not so sensitive to the extreme values. Mode is just simply looking for the overall average, but median's a little bit more specific. The median of the group, you have to do some steps before you can actually find it. The first thing you have to do is rank the items. That is, we arrange them in numerical order from least to greatest. Okay, so we write them all out in order. Then, if the number of items is odd, our life is super simple. We just look for the middle term. So then it doesn't matter how big the range is on our numbers. We're literally looking for the middle term. If we have an even number of items, then what we do is we take the average or the mean of those 2 middle items. And we're going to see an example of both of these. But both of these cases, whether we have an odd number of items or an even number of items, because we're really just looking at that central term, it isn't affected by the outsides as much, and we get a better idea of what actually is the middle or the central tendency of like this company or the grade point averages or whatever. So, and a lot of your problems, I went through your homework, a lot of your problems will give you a set of data. They will ask you for mean, median, and mode for all of them. So you're going to get practice with all of the different central tendencies today. For this, we're going to find median of each of the lists of numbers. So they give us a list, and A is really nice. We have 6, 7, 12, 13, 18, 23, and 24. We don't know what these numbers represent, and luckily, we don't actually have to know what they represent in order for us to find the median. Because this one's already represented in ascending order. We start with the smallest number and we get up to the biggest. So then it's, well, how many pieces of data do we have? 1, 2, 3, 4, 5, 6, 7. This one's super nice. It has an odd number. So I'm going to go to the middle number, aka the 4th term. That's it. No math required. The median of this is 13. The median age of this group of people is 13 years old. The median number of hours this group of people study is 13. Again, we can apply it to whatever these pieces of data actually mean. But finding the median of an odd number of data points, that's all you do. Now B, we also have ascending order. It's written in the right order. But B has 8 terms. So it's not, we can't just go to the middle because there's 2 middle terms. And so what we're going to do is we're going to find the mean or the average of these 2 middle terms. We're going to take 13 plus 18 and then divide it by 2. That'll give us a 31 divided by 2, which will be 15.5. So the median of B is 15.5. Now, what about C? What do we need to do first on C before we can find median? Yeah, they're not in the right order. That's kind of a bummer. So we got to write them in the right order. So 7, 9, 12, 15, 17. Oh, I skipped 13. 13's in there. 21, 32, 41. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9, so that means I'm going to go to number 5. 1, 2, 3, 4, 5. 15. You don't want to try and find the median without writing it in ascending order, because if I did that up here, 1, 2, 3, 4, 5, 21 would be my median, which is not actually true. So you always do have to take the time to write it in ascending order before you find that median. One thing to think about, and maybe a way to remember what median is, or keep it clear from the others, is think about when you drive down the road and there's a median in the road. It's that piece of concrete that's in the middle of the road that you don't want to ride up on. And so the median divides the road, or it divides the highway. That's what happens here when we're doing our list of data points. It's the median or the middle of them. So D is also not written in the correct order. Looks like 132 is the smallest. And then 147, 159, 174, 181, 253. 1, 2, 3, 4, 5, 6. There are 6 terms here. So I'm going to find the mean of the middle 2 by adding 159 and 174 together and dividing by 2. So again, the nice thing about the median is it doesn't matter how high and low our list of data points are. So it wouldn't be skewed quite so much by if somebody's making a lot of money or if somebody's not making a lot of money at the company and things like that, because it's really just looking for the middle. And as you will see working through problems, there's going to be times where the data is the same, and so you're going to get, that somebody worked 8 hours this day and 8 hours this day and 8 hours this day and 12 and 11 and things like that. And if you're looking for the average or the median of how many hours the people in this company work, well, if you have one person that worked 1 hour and you have one person that worked 20 hours, if I find the average of all that, it's going to be really skewed. But if I look in the middle and find the median, odds are I'm going to see more of what the actual average person is working in a given company. Any questions on median or mean before we move on to positions median? Okay. The next bit is not going to tell us the median. The next piece of information tells us the position of the median. So position of the median in a frequency distribution. Okay, this is going to be a little confusing until we start working through the problems, but then hopefully it'll make sense. The position of the median is where you take the number of elements plus 1 divided by 2. Or you take the sum of the frequencies plus 1 and divide it by 2. This is going to tell you where in the list of your data your median is going to fall without you having to write out all like 100 pieces of data, because that gets really tedious. And so this is going to combine the frequency distributions that we did in 12.1 with our medians and help us to figure out where that piece of information is without having to write out all of the data. So cumulative frequencies tell us how many items have that value or a lesser value. That's key. Because frequency tables, when we looked at them in 12.1, they tell us how often a piece of data happens. So how many people earned A in math class, that's a frequency. How many people earned C or better in a math class is a cumulative frequency. Because then I'm not just considering how many C's were earned, I'm considering how many C's, B's, and A's, because it's C or better. And so we have to make sure that we keep that straight, that cumulative means it has that value or a lesser value. And so here's what we're going to do. I know the examples in the notes, they're lacking because I get the examples from the lecture portion of the book, not from the problems. And so there's always some missing information that I try to present while I'm doing the lecture so that you know exactly what this problem is asking you. This one says we're going to find the medians for the following distribution. And we are not given much information whatsoever. We are given a value across the top of 1, 2, 3, 4, 5, and 6. And then we're given a frequency of how often we're getting that value. We get the value of 1 one time, 2 3 times, 3 2 times, and so on and so forth. And so I'm going to turn this table vertical and make a little bit more sense out of it so that we can actually figure out the median. Because right now I can't figure out the median without writing out all those numbers, and I don't want to do that. So I'm going to make a value column. And a lot of these problems are learning how to do the problems, so I apologize that there's not more notes per se. Then we're going to have our frequency, how often we're having that value. Then we're going to do our cumulative frequency. That's a Q in this last column. So the values are what are across the top. 1, 2, 3, 4, 5, and 6. And I'm going to go ahead and put a total down here as well. Now the frequency, again, is straight off of our table. So 1, 3, 2, 4, 8, and 2. And I'm going to figure out how many total numbers then, or pieces of data we're playing with here. Because the frequency tells us how often we're getting a piece of value, so that means we have 3 number 2s in this value set. So if I add up all my frequency, that tells me the total number of data points that I'm dealing with. 1 plus 3 plus 2 plus 4 plus 8 plus 2 gives me 20 pieces of data. Now, cumulative frequency, this is just like an extra note if you want. How many items have this value or less? Because that's how we find cumulative frequencies. So when I look at 1, that's the lowest value we have. The frequency of that is going to be the same as the cumulative frequency because there's no other option for us to have a lower value than that. It's 1. But when I go to look at the number of 2, well, you can be the value of 2 or you can be the value of 1. So how many were at the value of 2? There was 3 of them. But then there was also 1 at the frequency of 1. So my cumulative frequency is 4. This tells me that there's 4 pieces of data that have a value of 2 or less. And again, this is helpful if we think about if I'm trying to look at how many students have a C or greater in this class. I can do it with this kind of cumulative frequency. So who wants to take a guess at how much our cumulative frequency is for 3? That's right. We take basically the cumulative frequency from above and we add to it the frequency of the row we're in. So that would be 6. So then the next row would be 6 plus 4, which is 10. 10 plus 8 is 18. 18 plus 2 is 20. Notice that the cumulative frequency of our largest value is the total number of items. It has to be that way. It will always be that way. And so some people actually like to start at this end of it, and then they subtract to get all the way down. Either way you want to fill up your table or get that information, that's totally fine. Now, in order for us to find the position of the median, because I don't want to write out these 20 pieces of data. Well, 20 is not a lot. You're going to deal with problems that have 50, and I don't think you want to write out, 25 twos because the frequency of 2 was 25. So we're going to find the position of our median by using this information up here. It's the number of the items plus 1 divided by 2. So position of median, so POM, will be 20 plus 1 divided by 2, because there was 20 total items, and I'm going to add 1 and divide by 2. That's 21 divided by 2, 10.5. Well, we can't have a 10.5 position. That doesn't make sense. That makes us fall in between two different pieces of data, because we have the 10th piece and the 11th piece. So what we're going to do, so the median is the average, or mean, of the 10th and 11th term. Because I got 10.5 that falls between 10 and 11, so I'm going to find the average or the mean of those two terms. So then I have to figure out what's the 10th term and what's the 11th term. Who wants to take a stab at what is the 10th term and the 11th term?
4 and 5.
It is 4 and 5. How'd you get that?
Because 10's right there on the cumulative frequency, and then the 11 will be the next one.
Perfect. That's exactly how you read this table. So there's 10 items that will be 4 or less. So that means the 10th one will be a value of 4, which means the next one would have to come from the next cumulative frequency section, which is 5. So that is exactly right. Our 10th term would be 4, our 11th term would be 5, and we're going to take the average of those two. 9 divided by 2 gives us 4.5. So the position of the median only told us where it was. It told us it was at 10.5, which means we have to take the average of the 10th and the 11th term. So then we have to look for that 10th and 11th term. And the whole purpose of having like this little formula to do this and doing the cumulative frequency is it allows us to deal with the data when the data gets really big without having to write out all the pieces. Again, 20 terms isn't horrible. 2,000 terms, ugh. I don't want to have to find the 555th term out of 2,000 and then count and look for that. I want to be able to use my cumulative frequency to help me to eliminate out a lot of that work. So let's do another one. Same exact process, different values. You are trying to find the median of this value set. So I highly recommend doing a value frequency and cumulative frequency table. If you don't mind it being horizontal, you can actually just add on to the table that's there. That's not how I did it in my handwritten notes, but I will do that here so that you guys can see it if you want to save some writing. I am going to put dividers between all of our numbers, though. Where we're going to have cumulative frequency down here. So in order for us to have a grand total of how many pieces of data we have to add up our frequencies. 6 and 6 is 12, 12 and 8 is 20, 30, 35. There's 35 different pieces of data that we're playing with. So the frequency tells us how many are at that value, and the cumulative frequency will tell us at that value or less. So the smallest value is 2. So there's 5 of them at 2, so the cumulative frequency is 2. Who wants to take a guess at what is the cumulative frequency for 4? 13, because we take the frequency at 4 and we add it to the cumulative frequency here, which is 13. So then we do the same process here. For 6, it'll be 10 plus 13, which is 23. 8 is 6 and 23, which is 31. And then we had better get, did I add wrong? Yes. 6 and 23 is 29. I knew I had added wrong because when I was trying to add 31 and 6, I got 37. So I knew I either added my frequencies wrong or I was adding wrong somewhere here, because this last one, for my cumulative frequency of my largest value, should always be the same as the frequency total. Always. So I was able to kind of catch myself that I had made a math error here. So the position of my median is always going to be my total plus 1. 35 plus 1 divided by 2. 35 plus 1 is 36 divided by 2. So I need my 18th term. When you have an odd total number of elements, you're always going to get a nice answer where you don't have to find the mean to use the median. I just need the 18th term of this data value. So what is the 18th term? Or what is the value of the 18th term? 6. Yes. So here's how we know. If we look at our cumulative frequency, we have 5 that are 2 or less. We have 13 that are 4 or less, but we're looking for the 18th term. So that means we got to go further than 13. 23 of them are going to be 6 or less. And there's 10 of them between 13 and 23 that are 6. That means the 18th term lives between 13 and 23, so that means it has a value of 6. Questions on how we find median, how we use the position of median for our larger sets of data? Okay. Let's look at mode. I told you we're going to do mean, median, and mode. Those are the 3 M's that usually go together for central tendency. Mode is the data set value that occurs the most often. So if 12 of you have A's in this class, and we're looking at the A's versus, and there's only 20 of you in the class, that means A's have the majority of the class. So the mode for this class would be an A. It's looking for what occurs the most often. So literally all you're doing is looking for the repeated numbers and seeing which number or which piece of data repeats the most. That's it. So when I look at this first list of numbers and I'm looking for the mode, I'm looking for numbers that repeat. This one's easy because the only numbers that repeat are 49. So the mode is 49. Notice we did not have to reorder the numbers. They don't have to be written in a certain order at all. I will say most of your problems, though, will ask you for mean, median, and mode. They'll ask you for all of them. So if you go ahead and write them in ascending order, you're just helping yourself out on one of the other ones. But when it comes to mode itself, we're just looking for repeats. So if I look at my next set of data, I have 485 and 485. I also have 487 and 487. So I have 2 different values that both occur twice. So in this case, we're going to have 2 modes. We're going to have modes 485 and 487. We call this bimodal. bimodal. Bi for bicycle. Bicycles have two wheels. Modal, meaning two modes. You can have more than one mode. And that's okay. You just list it out side by side. What about C? What's the mode of C? Yeah, there isn't one. None of these are the same. So there's no mode. So mode has the least amount of algebra in terms of like computationally. And so you're allowed these other options of having more than one mode or having no mode. Now D looks like the value tables that we were just kind of playing with, where it gives you a value and then it gives you the frequency. We don't have to do any cumulative frequency computations or anything like that. What we need to recognize is the frequency is telling us how many times we're getting that value. So I get the value of 19 one time. I get the value of 20 3 times. And so if I'm looking for the mode, I'm looking for who has the highest frequency. So what value has the highest frequency? 22. There's 8 of them. That means the mode is 22. I don't have to write them out. I don't have to see them in a list. It tells me I get 22 8 times. That's my mode. And if there would have been another one that had the same frequency, then I could have another bimodal situation happening. There's 2 additional notes at the bottom. One of them I've already addressed, and that 5B is bimodal, meaning it has 2 modes. The other one is that mode is the only usable measure of central tendency with non-numerical data items. I do not have to have numbers to figure out mode. I could have colors. I could list everybody's favorite color, and I could tell you the mode of it, because I could look for which color shows up the most. What's everybody's favorite pizza topping? I could do that. And I could do that with mode. For mean and median, I have to have numbers. I would have to assign numbers to your favorite color or something like that in order to figure out anything about it. But mode, I don't have to have numbers at all. All right, let's do a couple. Yeah, we have 2 more actual problems, and then we're going to look at just some graphs. So we touched on stem and leaf very quickly because I was told to touch on it very quickly and told that we don't use it a ton. So we're going to do one example in this section. The stem and leaf displays the order, but it gives you also like a better example of what's happening. So I had a student come and ask how the stem and leaf worked, and so I wanted to make sure that we understand how stem and leaf worked. For the stem and leaf, this column over here pretty much works most of the time like your tens column in your numbers. And then all of your leaves coming off of your stem are like your ones. And so the way that we would read a stem and leaf is if I'm looking at this right here, I have a 1 in the tens place, a 2 in the ones place. That means I have a data point of 12, and it only comes up once. Then I have a data point of 14 because I'm still using the 1 as my stem, and my leaf is 14. And I have a data point of 15 and 16 and 17 and so on and so forth. As we move down to our second stem, these are our 20s. Notice that 24 happens twice, and 29 happens 3 times. They list it out multiple times. So this is really just another way of doing a frequency table. It's just a different way of representing it. So when I'm looking at these, what am I actually looking for in this one? I don't know what I'm looking for. I didn't write down the question. Oh, it's going to ask me a whole bunch of questions. This is all one problem. Thank you. That was the table. That's the data. And then we're going to find the mean, median, and mode. We're going to find all 3 of the informations that we've dealt with. So mean is where we take all of our data pieces and we add them together, and we divide by the number of data points. Now, I'm not told how many students are questioned here because it says this is a stem and leaf display for weekly study times with the leaves ranked. And so this means we have a student that told us they study for 12 hours a day. We also have a student who told us that they studied for 72 hours in a week. That's a lot of study time. And so we don't know how many students. But each of our leaves represents a student. So if I have 1, 2, 3, 4, 5, 6 leaves here, that means there were 6 students that had teens, between 10 and 20 hours of study time. This is actually the same data we used in the 12.1. We did study times here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 leaves here in the 20s. That was 9, 10, 11, 12 leaves here. 1, 2, 3, 4, 5, 6, 4, 2, and 1. So we can add all those up to tell us that we have 40 students that were questioned. We need that so we can figure out what the mean is. Now, this is one of those times where if you have a stat crunch on your Pearson, it's nice, but you don't always have that option because obviously this is a written out one, and so you would have to add up all of these data points. I'd have to take 12 plus 14 plus 15 plus 16 plus 17 plus 18 plus 22 plus 23 plus 24 plus 24. I'd have to add up all 40 pieces of this in order to find the mean. Is there a shorter way to do it? Not unless you have some digital help. What I mean by that is like having StatCrunch or something like that. So we would take 12 plus 14 plus blah, 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 all the way until we have plus 60 plus 62 plus 72. Like we'd keep going, keep adding, keep adding. And we would divide all of that by the total number of students questioned, which was 40. That's 1414 is the total number of hours that students studied. We're going to divide that by 40 to find the average number of hours these students study. 35. That is your mean. And I remember this problem from 12.1. That's the number of hours they spend both in class and out of class studying. And you may say that seems like a lot. If you're taking 15 hours of credits, that means you're sitting in class for 15 hours every week. In college, you're supposed to spend 3 to 6 hours per credit hour on your classes outside of class. So it's really not actually that absurd. Now, whether or not you actually spend that, that's a totally different argument. Some classes require you to spend more than that, and some will obviously require you to spend less. Now, the median, if we figure out the position first, that's going to help us narrow in where we're going. So remember, position of our median is n plus 1 divided by 2. So that was 40 plus 1 divided by 2. 41 divided by 2 is, what is it? 20.5. So we have that 0.5 situation, which we don't have a 20.5 term. So we need to find the average of the 20th and 21st term. Well, we have 6 here. That gives us 15 here. This is going to give us 27. So they're both going to live in here somewhere. We need the 20th and the 21st. So if I had 15, 16, 17, 18, 19, 20, 21. So what is my 20th and 21st term? 33 and 33. So in this case, since they're both actually the same, we wouldn't actually have to find the average because you're going to see it's going to give us 33. Because if you take 33 plus 33 and divide that by 2, you get 66 divided by 2, which gives you 33. So that's kind of a unique situation that happened in this case. It doesn't always happen, obviously. So I used my totals over here to kind of help me hone in on where I need to look. But then I just go and I keep counting until I got to my 20th and 21st. So the position helped because then I didn't have to think, okay, there's 40 students, so I need to get to the 20th and 21st, and then I didn't have to count. Again, these are all tools to help us to simplify the process a little bit. Now C is the mode. This is the value that's displayed the most. So I need to go up here and look at my leaves. I know I've got 3 9s here in my 20s category. Do I have anything that has 4 in the same row? Yeah, I got 1, 2, 3, 4 here, which means the number 36 comes up 4 times. I don't have that anywhere else. So that means C is 36, because it's just which value comes up the most. That's my mode. So for this problem, if I have it in paper and pencil, the most work I really have to do is adding up all those numbers. It gets a little bit tedious, I understand that, which is why I won't give you 40 pieces of data if I make you do it that way. Are there any questions on how we do mean, median, and mode, or how we do the position of the median to help us locate that median? Okay. We're going to flip over. At the back, there's nothing to do on. The back is reference. There's a lot of symmetry that will come up in our data sets, and we will actually talk more about this as we progress on, because we're going to talk about normal distribution later on in this chapter. And so we want to see where there is symmetry in our data sets and where there's not. So symmetric data sets, that's a pattern of frequencies with the same or nearly the same, so that as we move out from a central point, it does the same thing. Non-symmetric or asymmetric data sets, those have patterns towards the left and right that are significantly different. And so if we have somebody in the class who gets a really high grade on a test and skews the average, that's what happens. It's more like what skewed to the left or skewed to the right. Like they had a really low grade and everybody else did great, or we had one person that had a really high grade and everybody else kind of went downhill from there. What we like to see, especially teachers, when we're doing grades and stuff, is we like to see something more like a bimodal distribution here. This looks more like a normal graph, where the average amount of students fall here in the middle, and then you have your outliers that did really good or really bad. You can have uniform distribution where it stays pretty much the same going across. This one's a bimodal distribution where you see we have two little peaks. That also happens. And so these bottom ones are more the asymmetric or non-symmetric form, because you notice they're a little wonky, or they're skewed to the left or skewed to the right. These are more centrally symmetric. And so just looking at them, just kind of having a taste of that. We will see more with this, like I said, when we talk about normal distribution later on. And then I really liked just the summary table at the end of the notes section in the book, where it just kind of reaffirms what the mean is, what the median is, and what the mode is. Where mean is kind of your average, median is your middle, and mode is which one happens the most often. I know some of the first questions on your homework are concept questions, and a lot of times your concept questions come from the definitions of these different topics that we are learning. And so I liked having this at the end, just so you can kind of have a quick reference of what all three of these are as you go through your homework and stuff like that. Are there any questions?